Hello dear students, this is Devinder Kaur and you all are welcome to my YouTube channel The Enlightened Room. In this video we will discuss about our new topic cause of dispersion. So let's get started. Now before discussing about the cause of dispersion, let us revise what is dispersion and what is visible spectrum. So we have already discussed in the previous video that when a beam of white light is passed through a glass prism, it splits up into a band of 7 colors. This band of 7 colors is obtained on the screen on passing white light through a prism, and this is known as spectrum. As all the colors in this spectrum are visible to our eye, it is rightly called as a visible spectrum. Every color of the visible spectrum has its own characteristic wavelength, and therefore it also has their own characteristic frequency. So let us take a quick look on this. Since the frequency of violet color is maximum and the frequency of red color is minimum, it could be said that the wavelength of violet color is minimum and the wavelength of red color is maximum. This sequence of colors in the visible spectrum from the low end is given by a famous acronym VIBGYOR, where V stands for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange and R for red. A spectrum in which different colors occupy their own distinct positions without any overlapping whatsoever is called a pure spectrum. On the other hand, a spectrum in which different colors of light overlap one another is called an impure spectrum. Well, in practical life, the spectra we observe are impure spectra or impure spectrum. For obtaining pure spectrum, certain specific conditions should be satisfied. But in real life, in our practical world, we are only able to view or only able to be visible to see the impure spectrum. Now let's discuss about the cause of dispersion. Now, as already discussed, when a beam of light is passed through a glass prism, it splits up into 7 colors. This splitting of white light into its constituent colors is called dispersion of light. The cause of dispersion can be understood as the different colors of light are categorized by their different wavelengths or frequencies. So all the colors travel in air or vacuum with the same speed, but their speeds in any other refracting medium like glass or water are different. For example, in glass, violet color has the minimum speed and red color has the maximum speed. So the refractive index of glass can be written as N equals C upon V. Now V is different for different colors. Therefore N is different for different colors. We can also say it as that V of violet is less than V of red. Therefore N of violet will be greater than N of red. That means the refractive index of glass, which has been denoted as N, is for violet is more than the refractive index of glass for red color. Now, a ray of light on passing through a glass prism suffers 2 refractions, on going from air to glass, and the other one is in going from glass to air. So the net deviation suffered by the ray varies directly as the refractive index of the material of the prism. As the refractive index of violet is greater than refractive index of red, the deviation suffered by the violet color is greater than the deviation suffered by the red color on passing through the prism. That is why violet color is at the lower end and is of the visible spectrum, and the red color is the at upper end of the spectrum. So all other colors of the spectrum lie in between these 2 colors. So hence we conclude that the cause of dispersion is that different colors of white light having different wavelengths deviate through different angles on passing through a glass prism. That is why they split down or they split out or they split on coming out from the prism along different directions. So this is up for today's video. In the next video, I will discuss about the recombination of spectrum colors. So stay tuned, stay healthy, and if you haven't subscribed to my channel yet, then subscribe to my channel. Thank you so much.
Pas de soleil, pas de soleil, pas de soleil, pas de